All right, so up to this point, we've been discussing two-step problems, okay? Step one is just writing down the number you start with, whether it's 68 grams of a substance, how many moles of tin do you have? Or if you have 0.385 moles of zinc, how many grams is that? So that is ways you go in opposite directions, but just a two-step process. When we talk about grams to atoms or atoms to grams, those are three-step problems. Okay, so as we take a peek at that, page 8.6, okay, that's where we have left off. And as you look at the top of page 86, yeah, anyway.
We were only short 2. Now we're missing 6. Now we're missing 3. 1,
Yeah.
2, 3, 4. Oh, we got it. Mine is my locker.
Okay. There's one. Okay.
But that's still 4. Is Xander's still not missing? But there's a new kid that took 1. But Xander's gone. So she's missing 2.
There, so one is unaccounted for.
Yeah. 2.
Okay. Yeah, you can go grab it. That's fine. Okay, well, doesn't matter. Anyway, we better get rolling. Page 86, conversion with Avogadro's number. What is that number? It's a constant. To the 23rd power. Yes, that is correct. Okay? So, why might you ever need to utilize this number? Well, how many, let's say, I've tried fishing. I'm not a fisherman, but some of you probably enjoy it. Do you like fishing from shore or on a boat or ice fishing? Okay? So one of the things that could possibly happen when it comes to ice fishing is perhaps the game fish in parks or different scientists that deal with wildlife may want to measure the oxygen levels inside the water, because what happens is as that ice freezes over on top of a lake, they need to keep track of how much oxygen is present in there in parts per million. Now, that doesn't mean anything to you now. That's what we call quantitative chemistry. We do a short segment in here called qualitative chemistry, which deals with what substance is that. Quantitative is what it is and how much of that. So you would need to utilize this number to calculate what is the oxygen levels in there to sustain a viable fishing or the fish level inside there. Otherwise, what happens, sometimes you can get winter kill in the spring. It doesn't necessarily just happen with grass and plants. It can also happen with fish. So if you were that type of an individual dealing with the game fish in parks, it's something that you'd want to constantly monitor. So there is some practical applications for this utilizing Avogadro's number. So you still have the opportunity to read through the sample problems. Okay? That just shows you how to do these. We just go ahead and jump right into that of the practice problems. Okay? So in this case, what we see, well, let's go ahead and read through the top of page 86. Okay? So figure 11 shows that Avogadro's number can be used to find the number of atoms of an element from the amount of moles, or to find the amount of an element in moles from the number of atoms. And I believe if you back up a page, that's showing you, that's why we show these arrows going in opposite directions. Okay? It's showing you, well, are you starting with mass of elements in grams? Then with a molar mass, you can find the number of moles. And then with Avogadro's number, you can find the number of atoms. So vice versa, you can start with the number of atoms, start working on your way to the left with Avogadro's number, find the number of moles, and then convert that to grams. So it just depends what number you're starting with and what you're trying to convert that to. All right. So while these types of problems are less common in chemistry than converting between amount of moles and mass in grams, they are useful in demonstrating the meaning of Avogadro's number. Note that in these calculations, Avogadro's number is expressed in units of atoms per mole. All right. Do you think you want to do all three or just pick one of them? Asking for input.
We start with one, and if it's easy, we're good. And then
Okay.
if it's not, keep going.
Is this gentleman your spokesperson, or do we just ignore what he says?
Ignore it. Nah, I think it's pretty good.
Okay. Well, I tried, but okay. We'll start with number one. Okay. So how many moles of lead? Okay, are in 1.50 times 10 to the 12th atoms of lead? Do not use the caret symbol. Why not?
It's not the right symbol. Scientific notation.
Yes, we want scientific notation, not exponents. Although the 23rd is an exponent, but it's showing you how many times you're moving the decimal place. Oh, to do these types of problems again, right? Yeah. Suppose I could have erased this earlier, then we wouldn't have to be going through this again. Okay. So for future reference for myself, when you are in Ms. Doctor's room, you're doing work on a smart board. It's not, is it called Emoto, or is that the math program, or?
Something like that.
Okay. Which do you prefer? Those types of smart boards or this? Okay. And that's, I would agree, but I still would have to know why.
Never have to worry about it now.
Oh, that happens, huh? Okay. All right. So in this case, there's only one place to start, and that is with how many moles of lead are in 1.50 times 10 to the 12th atoms of lead. Okay. So 1.50 times 10 to the 5th atoms of lead. Okay. I was just seeing if anybody was paying attention. Okay. Can't get anything by yourself, right? Yeah. It's 12. Yeah, it's 12. Okay. So then, in this case, how many moles? Okay. So for this conversion factor, we got step 1 done. So you can actually back up one page to figure 11. And when you see this in the middle box here, what it's showing you, okay, we are in moles, right? Or excuse me, we are in atoms all over here. So how do we get that to moles now? We have to use Avogadro's number. You might be asking, well, how do you know whether it goes on the top or the bottom? Well, if we've got atoms on top in step 1, where does atoms go in our next step? Bottom right. Okay? So atoms of lead gives us a mole of lead. But we need to use our constant, which is Avogadro's number, which is 6.022 times 10 to the 23rd. We've got them to cancel. We're in moles of lead, and that's what the question is asking. So I'll look at my cheat sheet here, and looks to me like we're supposed to come up with 2.5 times 10 to the negative 12th. Nope, we divide, okay? So, as a review, okay, we have a calculator like this? Okay. Alrighty. Is anyone still having problems, or maybe from time to time having problems punching these into the calculator? Say what part? Oh, 2.5 times 10 to the negative 12th. Well, it says 2.49, but I just say 2.5 times 10 to the negative 12th.
I got 2.5 times 10 to the
I got syntax error.
36. 10 to the 36.
Like, can you just go through all and put it in your calculator again?
Okay, so we take 1.50, your second function. Look for the two little e's, or x to the negative 1 power. Then an e should pop up on your calculator. Okay, then we should get a 12. You punch that in, and we divide that by Avogadro's number. In 2.49 times 10 to the negative 12th. Okay. You are multiplying rather than dividing.
I got 2.5.
You don't have to do that.
No, that's what the exponent function does. Okay, so start over. So punch in 1.5, second e to the 12th, divided by 6. Oh, what, you got a parenthesis. You have a parenthesis in there? No. Okay. Second exponent, 23.
Oh, actually, I think I might have forgot the 0.
Okay.
2, 4. Never mind.
Right now we have like 3 variables, right?
I forgot the 0.
How do you know to
All right.
multiply the top two or divide the two on the right?
Are we good with this?
No.
One of the things you might notice, as opposed to physical science, we probably move just a little bit faster.
So how do we know when to divide those two or multiply the top two?
If they're next to each other, you multiply. If
Like right now we have 2 that are over top of each other and 2 that are next to each other.
Well, I'm talking about the 0 from the 2.
That might have been that.
That's what I think.
If it's on the bottom and there's a line, then just make multiply with
Yeah. If it's on the bottom, you divide. If it's on top, you multiply. Okay? Are we good over here? Oh, you got one of those calculators. Oh, we can figure this one out, I think. Okay? So what I want you to do is punch in 1.5. Go ahead and punch 1.5. Okay? Then that EXP, you see that? Okay? Hit that. Then go ahead and hit 12. Now divide symbol. Okay? Then punch in 6.022. Your exponent, and hit 23 equals negative 12. Yep, that's what we're looking for. All righty. It's maybe a little confusing because this is new material. Yes, would you agree? It's one of those aspects that once you catch on, you're going to think, oh, it wasn't as bad as I thought. Left side, are we on the bus here? Okay, middle. That wasn't very convincing.
I just gotta think through it a little harder.
Okay, and then right side. Okay, so one of the aspects that you can do, okay, we said you can always go back to these.
There.
Yeah, you can always go back to these sample problems. So in this case, let's see here. Notice that we're starting with atoms.
Yep.
See how moles is on top there, and what we have for moles, and that Avogadro's numbers on the bottom.
Yeah.
They're dividing them two as well.
We use that number when we're dealing with atoms, right?
Yes.
Okay, then I'm good.
Okay. More practice. One more. Or move where we're going the other direction. Okay. So if we are going to go back in the other direction, okay, and actually add a 3-step problem. Okay. Page 87, practice problem number 1. What is the mass in grams of 7.5 times 10 to the 15th atoms of nickel? Okay. The only place to start is with your atoms of nickel, 7.5. This one's 3 steps. It's not 2 steps, it's 3. Okay? So with that, again, we got 7.5 times 10 to the 15th. That's probably where that 15 came from earlier, right? Yep. Okay. Okay. So, yeah, it usually takes up more space than what you think. And maybe it doesn't quite have to be that long. Let's not short ourselves. All right. Otherwise, you only end up with about 5 cents. Freshmen thought that was pretty good. That sounds diabolical, don't it? Yeah. Or like a parrot. Oh. Pig leg, pig leg, pig leg. Okay, yeah. Okay, so our conversion factor for atoms in moles is a constant value, just like 9.8 is a constant. So to get rid of the atoms is which constant? Avogadro's number. And does that go on the top or the bottom? Okay, so for every 6.022 times 10 23rd atoms of any substance, in this case nickel, you get a mole of nickel. Okay? Now, our atoms have canceled. We're in moles of nickel now. How do we get rid of that mole? Put a mole on the bottom. For every mole of nickel, how many grams of nickel do you get? Did we just make that number up? No, we did not. It's not a quinky dink. It comes from this right here. Better have one of these. Okay. Yep. You can even take that. Oh, that's cut off a little bit. That's only to column 2. That's not the right one. Let's try this one instead. That's a little better. Okay. Do we want to work on this one together? Yes. Okay. Has everything canceled out like we like? Our atoms are gone. Our moles are gone. We're in grams, and notice that the question asking, what is the mass in grams? Okay. So what I would suggest how you approach these problems is as follows. Okay? So take 7.50, and some of you have different calculators. Like we got individuals who use EXP, that means exponent. Instead of scientific notation, that's fine. That's different than that caret symbol. Okay? So second, your double E to the 15th. Since we've got numbers on top that are next to each other, what do we do with this and this? You multiply them. And if somebody's already done you should come up with 7.3 times 10 to the negative 7th. Let's see if that's what we get.
Oh, I got 7.3 times 10 to the 39. So
You're, yeah, okay. Times 58.65 equals. Now, there's still another step. You might get 4.40 times 10 to the 17th, but we got to divide by Avogadro's number yet. Okay? So now we divide. You just hit the divide sign. It takes that previous answer. 6.022 second exponent 23rd. And it might spit out a whole number, 0.00000073. Was that the right number of zeros? I wasn't even paying any attention. Yeah. Okay?
You always multiply in this first and then divide.
I got the same answer when I did division.
You did this step first?
I did division and multiplying, and then I did the multiplying and then division. And
Well, you don't do it twice.
No, I tried
Oh.
it both different ways.
Okay.
I got 7.32 times 10 to the 30.
Okay.
Multiply first to
Do you have to put the
I would multiply first, then divide.
Do you have to put the multiplication sign in, or can you just do
No.
7.5?
Okay. So let's try it your way. So 7.5 second exponent to the 15th. Divide that by Avogadro. And that's going to give us this number. Okay. So now, ideally, if we take that times 58.65, we get this.
6 zeros and then 7 3.
Yes.
Yeah, okay, so I
Yep.
did times and then.
Oh, don't do that.
Yeah,
Then you're just being redundant. Yep.
That's my.
Which is a good point. When you do that, it's changing it to that mode. Otherwise, you are taking it times the 23rd power. Those are two totally different functions. Yep. Yes? Well, just throw that calculator away. Okay. So go ahead and punch in 7.5. I don't think you need, did you put parentheses in there? Okay. Okay, go ahead and take that times. Okay. Let me, calculator please. Let's go ahead and we will clear all that out. So 7.5. Okay. To the 15th power. We're going to take that times 58.65. Okay. Gives us that answer. Then we're going to divide that by 6.022. There we go. That's what we're looking for. Yep. Oh, well, that's just written out in a whole number. So what that's saying, that's what, to the 7th power, is that right? To the negative 7, what it's saying is 1, 2, 3, 4, 5, 6, 7. So those are the same answer. This one, or 7.3 times 10 to the negative 7th. Same thing. Are we on the bus?
Yeah. Nope.
Okay. Otherwise, you might have to jump out of the way. Don't get run over. If you're on the bus, that means you understand. It's just my way of asking. Okay, well, that's just where we need maybe just that little extra practice. Okay, number 2 or number 3?
3 looks hard.
Yeah, 3 looks hard.
Gesundheit. So is that good or bad then?
That means you should do 3.
We should do number 3. Okay. So number 3. Number 3 on page 87 says, what mass of gold contains the same number of atoms as 9 grams of aluminum? Okay. Okay. Right. Okay. Number 3, we don't do problems like that because it's kind of redundant because you'd be using the molar mass twice. So I don't think we should go down that road, but we can. Otherwise, number 2. All right. So number 2 says, how many atoms of sulfur are in 4 grams of sulfur? So one place to start, 4 grams. Okay? Probably about 95% of the time you see a number in grams, you're probably going to change it to moles. Okay? And that's the case here as well. How do we change grams of sulfur to moles of sulfur? Nope, that's too far. We got to put grams of sulfur on the bottom, then put moles of sulfur on top. Okay? But how many grams of sulfur are in 1 mole of sulfur? .06. Okay. What do you think we do in our 3rd and final step? Okay. So we want moles of sulfur on the bottom. Then we put atoms on top. Your moles are gone, then you're in atoms. So we'll have you work on this and see if you can obtain this answer.
Dumb way that has the answer before you do.
And I know this isn't the most fun thing to do, but the reason we're going over is because if you see this in college, this is probably what you're going to be starting with in college.
Is this 22 or 23rd power? 22. The other one's 23. What?
Avogadro number. Oh, is that the? Oh, wow, I am dumb.
What's
Okay.
a 7 for?
That is.
That's your answer.
I got it right. First one I got right.
Okay?
Yeah, I got it.
Awesome. Okay. Now, keep in mind, the class sizes for chemistry have been quite small in previous years. Cooperative learning is fine. What can be the problem with cooperative learning? When you, and not that We like assigning quizzes and exams here, but we want to make sure that you are ready for that the next time you see this content. Okay?
So we have a quiz.
Next week, maybe. We just verbally talk about it. Molar mass, you could say that's a vocab term. Avogadro's number, you could say that's a vocab term.
There's not much vocab terms.
No. Nope. The last thing I want to do is let's see how much of this we can actually remember. Okay? Can I erase this? Okay? Like I said, let's see what we actually remember. Okay? So, someone go ahead and pick a number between 1 and 100.
37.
So I like 7. Let's keep it nice and simple.
One's pretty simple.
So, yeah, but we might get that one wrong. Okay? Element number 7, what are we talking about? From your physical science years. Nitrogen. How do we know that?
It is number 7.
So that 7 is trying to tell you something. What is everything about subatomic particles at the atom level that you can tell me about nitrogen looking at this information?
That was a lot of words.
Not the charge.
Oh, I was about to say, it needs some electrons.
Oh,
It needs some electrons,
Oh, yeah.
that's 5. What's
some protons, and some neutrons. How many protons does nitrogen have?
6? 5. 5. 8.
Wait a second, bro.
Wait.
-3?
No,
7.
So for
7.
How?
There are 7 protons.
7
Oh,
electrons.
that's the number.
This identifies your element. If it is neutral, what type of charge do protons have? It's positive. And if this is a neutral element, how many negative charges would it have? It would also have 7, but which one of these has a negative charge?
Electrons.
Is it the neutron or the electron? You know, it's just a lucky guess. You hit the jackpot.
Yeah.
See? Because, yeah, you hit 7s. That's a jackpot.
I'm trying to figure out where you got the 7s from.
I thought we were doing the
The,
table thing.
oh my lord. Protons, neutrons, and electrons.
It's the same for all of them?
It's just a coincidence. Now we can do Ben's choice.
I'll get it wrong.
Oh, there it is, Ben.
1.
There is 1 proton
1 proton,
and 1 neutron.
No. 8.
1 electron,
1 electron,
0 neutron.
0 neutrons.
Darn tootin'.
How you know that?
I'm just like that, I guess.
You actually guessed?
Something about like E equals MC
Okay?
squared.
No. Okay. Let's someone pick a D block element. There's some vocabulary for you. Where's the D block?
That's metals, isn't it?
It is,
Oh,
but there's a lot of metals on here.
I'm feeling some
28.
stat.
28. That is nickel. So what is nickel's atomic mass?
58.69.
You can't have a partial neutron. So when we start talking about these moles and masses, it's coming from the number of neutrons and protons that are actually in the nucleus. Does anyone remember why we don't talk about the electrons when it comes to a mass?
They don't weigh anything.
Well, those are the most important, actually. No,
They don't weigh anything.
they are so small that you really disregard their mass, but they have a charge though. How did you know that?
Well, if we're talking mass,
Yeah,
and we disregard them, then odds are
that's
they're
right.
gonna be
Okay, so what can you tell me about nickel? How many protons?
in it. 28.
Okay, but we're going to say it's got a +3 charge because nickel can be +2 or +3. So then, how do we find the number of electrons then? Well, if we were to subtract these, that would be what, 29, right?
I was taught.
Okay, so if it's neutral, it would be 29. But if it's a +3 charge, does that mean it has 3 more electrons or 3 less electrons?
More. Or 3 less.
Well, if you say them both, then you won't get it wrong.
Less.
Yeah.
So it's got 28.
So it's, in other words, if you're calling a power play, but then you say a counter at the same time, you can't get it wrong because they're both going in opposite directions.
Lead counter left.
Yeah, lead counter left.
Yeah. Instead of power right.
Lead counter right.
We should add that now.
Okay? All right. Did this confuse anybody? Okay? That's what you got a calculator for. This tells you the number of protons, okay? The number of neutrons, however, you subtract these two numbers, 57 minus 28. If it's neutral, there would be 29. But this is saying that you've got 3 less electrons than you do protons. Therefore, that is going to be 26. Yes? That is the atomic mass of nickel.
No, it's
If you, oh, it's 58. Okay.
58.69.
Okay, so then we just round that up to 58. Because you can't have a partial neutron.
Did you round it up to 59?
Yes, 59. Okay, that changes things just a little bit.
It'd be 31 then.
Okay,
Yeah. 31 if it was
So how do you find neutrons and electrons?
it was neutral.
okay, so protons equals 28. Neutrons,
I thought we had the +3.
well, we haven't got that far yet.
Oh, okay.
What happens when you subtract them? You get 31, right?
Yeah.
And if this was neutral, you would have that, right? But it's got a net charge of +3.
Yeah.
So that means, are there 3 more electrons or 3 less electrons?
More.
3 less.
They're negative.
There you go.
So could you just add 3? You have 31 and 28, and not 28 and 25.
Well, it can if it's got a negative charge instead. All right, we'll pick up with this next time.